Hello everybody, in today's lesson we're going to be talking about some general questions in review that you might encounter in your let me make the brush size bigger, that is way too small, in your AP Calculus BC course. So first off, we can start off with a word problem, and the word problem states that if gravel is being dumped from a conveyor belt, so something like that, into a conical shape at a rate, and it fills up at a rate of 30 cubic feet per minute, such that for the conical diameter and height are always equal, so the diameter is equivalent to the height of the cone. How fast is the height of the pile increasing while the pile is 10 feet high? So while this is 10 feet high. So we know the volume of a cone is 1/3 pi r squared times h. Now since the diameter divide r equals diameter divided by 2, and the diameter is equivalent to h, so then the radius is essentially h divided by 2. So it's 1/3 pi h divided by 2 squared times h. I'm gonna simplify this, which is equivalent to 1/3 h cubed divided by 4, which is 12, or h cubed over 12. Right, now that we have the volume of the shape figured out, we can now we're going to take the derivative of it on both sides in respect to t. So dv over dt to figure out the rate that the pile is increasing. So dv over dt is equivalent to 3h squared times h dh over dt divided by 12 squared. So times 12, this is just quotient rule. So now what we get is h squared times dh over dt over 4. Now we know that the volume is filling up at 30 feet cubed per minute, which means dv over dt is that. So 30, so we write the equation 30 is equivalent to h squared. Current h is 10, so that's 100. Then dh over dt, you don't know that, so let's just do h slash for simplification over 4. So the answer is 120 divided by 100, which is 12 divided by 10, which is 6 divided by 5. That is equivalent to dh over dt. And the solution to our question, how fast is the height changing for this question? So there we go. Now another question you might encounter is finding critical numbers. So critical numbers of a function, so of fx. And I'm going to give a question about it. So let's say function is f of x is equivalent to x cubed plus 6x squared minus 15x. What are the critical numbers of this function? Well, we know to find critical numbers, we use extrema theorem. So we first take the derivative of this. So we use 3x squared plus 12x minus 15. And now we can simplify this by taking 3 out, so x squared plus 4x minus 5. And then we can expand that to be equivalent to x plus 5 times x minus 1. Okay, so you know that there is going to be a critical point at x equals -5 and x equals 1 by looking at this here. So now how we need to figure out what type of critical points these are. So you take the double prime of what you have already got, which is this one. So take the double prime of fx, which is 6x plus 12. Now I plug in -5 into 6x plus 12, which will be -30 plus 12 for double prime, which will be -18. So that's a maxima, critical point. And when you plug in 1, it will be greater than 0, so that would be a minimum. So that's how you do critical numbers. Really simple. Now, finally, we're going to, so we're also going to do another question relating on extrema, finding the absolute maximum and minimum of, let's say, of values f of x in a given interval. So given interval. So let's say you have a function f of x equals x minus ln x, and the interval is half to 2. You want to find out the absolute maxima and minimum of this. Well, we do this the same way. You find out the derivative of f of x, which in this case would be 1 minus ln derivative of x, just 1 minus 1 over x, which is equivalent to x minus 1 over x. Now, given that this here, we simply just plug in our intervals in here. So these intervals, first of all, when we plug in half, it would be -half over half, which would just be -1. So when it's half, when f prime is half, it will be equivalent to -1. And when f of prime is 2, it will be equivalent to 1/2. Now, to find extrema, we also know that another possible solution is when f prime of x is equivalent to 0, which is equivalent to x minus 1 over x. So x is also equal to 1. Now, which one is the greatest? X equals 1 is the largest. So we have these possible answers for maxima and minima, and what we do next is that we will take the double prime of f of x to figure out which is which, just like the previous question. Alright, so now let's find out which one is greater. So we take the double prime of x minus 1 divided by x. So we take the double prime of this. So let me scroll up a bit so we get more room. So let's say f of prime is already x minus 1 divided by x. So f of double prime of x would be that primed. So x minus 1 prime times x plus x prime times x minus 1 divided by x squared. So that will be x plus x minus 1 divided by x squared. Okay, so now that will be 2x minus 1 over x squared, which is double prime. And what we do is that we simply just plug in the numbers we got, -1, half, and 1. So we have to plug in -1, half, and 1. So when x is -1, we plug it into f of double prime will be equal to -3 over 1, which would be -3. So we know this will be a maxima of some, but we don't know if it's absolute yet. So f double prime of half give us 1 minus 1, which would be 0. So it would be 0. So that will be this will be a changing point on the function. So, or inflection point, and then when x is 1, it would be simply 1. So we know that's a minimum. So in this scenario, this will be our absolute maxima, this will be our absolute minima, and that's your answer. So Lastly, another question you might encounter of is that when you're given, let's say, a function like 2x cubed plus 3x squared minus 36x, you want to be finding what intervals is f of x increasing or decreasing, or the other way. So in order to find this out, we can again find out the maximum and minimum point of this function, and then with the let's pretend this might let's pretend this function is something like that, right? We just explain the general idea behind it. You find out the maximum minima, so let's pretend the maxima here and the minima here, which will tell you what parts will be increasing, like here, decreasing here, and then increasing again. So things to the left of the maxima will be increasing, and right to the maxima will be decreasing, and it's vice versa for minima. So when you find out maxima minima, you find out the correlations here, which will also give you the concavity of it. And you know, in between here somewhere, it's an inflection point, because that's where the direction changes. Also, by finding out this, you can extrema theorem can be applied to many different scenarios. You just have to essentially think it out on a graph. So I know this lesson was a bit long, but I hope you found something useful out of it.